Good morning, y'all. I want to begin today by talking about something that almost never gets its own dedicated forecast discussion. Something that operates so far above the ground, so far removed from the rain on your windshield and the wind against your house and the hail on your roof, that most weather coverage treats it as background infrastructure rather than as the subject of the story itself. The jet stream. Not the storms the jet stream produces, not the tornado outbreak or the flood event or the derecho that the jet stream enables and organizes and energizes. The jet stream itself. The thing underneath all of those things. The engine that has been running quietly in the background of every significant weather event this channel has ever covered. And that is now, right now, in the current model guidance, across multiple independent modeling systems, with a consistency that has been building for the past 5 days. And that has now reached the level of certainty that demands a dedicated, focused, unhurried conversation. About to do something that the communities in the path of what it produces genuinely need to understand before it happens. Because what the jet stream is about to do is not produce a storm. It is not going to organize a squall line or set up a dry line or create favorable shear for supercell development in the way that it does dozens of times every spring. What it is about to do is go wild. And I mean that in every precise, meteorologically grounded, historically documented sense of the word. The jet stream is about to undergo a configuration change, a structural pattern-level reorganization that places it in a regime that the historical record associates with the most significant, most widespread, most consequential weather events that the central and eastern United States experiences, not in any given spring, in any given decade. And I want to make absolutely sure that every person watching this video understands what that means for them, for their community, and for the decisions they need to be making in the next 24 to 48 hours, while the preparation window is still open. Let me build the foundation of this forecast from the ground up, or more accurately, from the top down, starting with what the jet stream is, what it does in its normal operating state, and what happens when it departs from that state in the way the models are now advertising. The jet stream is a ribbon of fast-moving air in the upper troposphere, typically between 25,000 and 40,000 feet above the surface, driven by the temperature contrast between the cold polar air mass to the north and the warm subtropical air mass to the south. In its normal, relatively undisturbed state, the jet stream flows roughly west to east across the continent, not in a perfectly straight line, but in a pattern of gentle, progressive waves that meteorologists call Rossby waves, each one carrying a ridge of high pressure on its downstream side and a trough of low pressure on its upstream side, moving steadily eastward across the continent and carrying the parade of weather systems with them. Progressive, organized, predictable within the normal range of forecast uncertainty. That is the normal jet stream. That is what it does in the 40 weeks out of 52 that do not produce the kind of forecast I'm making right now. And then there are the other weeks. The weeks when the Rossby waves that normally move steadily eastward instead amplify, grow taller, dig deeper, slow down, and in the most extreme cases, stop moving altogether and lock into a configuration that the atmosphere maintains for days to weeks, rather than the usual 2 to 3 day cycle. Those are the weeks when the jet stream goes wild. And based on what I am seeing in the model guidance right now, this is one of those weeks. The specific configuration the jet stream is locking into is something that meteorological community calls a highly amplified omega block, named for its resemblance to the Greek letter omega when you look at the upper level height pattern on a weather map. A ridge of anomalously high pressure building over the central part of the continent, flanked on both sides by deep cutoff troughs, one over the western United States and one over the eastern United States, with the jet stream forced to flow around the outside of this entire structure in a pattern that looks, from above, like a massive loop stretching from the subtropics to the Arctic and back. Omega blocks are not rare in an absolute sense. They occur several times per year, somewhere in the northern hemisphere. What makes this particular omega block configuration historically significant is 3 things happening simultaneously. First, the amplitude. The ridge at the center of the block is forecast to build to heights, measured in geopotential meters at the 500 millibar level, that represent anomalies of +3 to +4 standard deviations above the climatological mean for this time of year in this geographic location. +4 standard deviations is not an unusual ridge. It is an extreme ridge, a ridge that statistically occurs at this intensity perhaps once or twice per decade in this geographic location. Second, the persistence. The ensemble guidance is advertising this block remaining entrenched for 7 to 10 days. Not the typical 3 to 4 day ridge event, but a genuine, sustained, week-plus blocking pattern that allows the full suite of downstream consequences to develop and compound. And third, the positioning. The omega block is positioned in a way that places both of its flanking troughs, the western trough and the eastern trough, over populated meteorologically vulnerable portions of the United States simultaneously, with the jet stream's southern branch focused directly across the Gulf Coast states and the south central United States, in a configuration that maximizes moisture transport, instability generation, and severe weather potential across the exact geography that is most vulnerable to those hazards. And this specific geographic positioning are not subtle, and I want to walk through them with the specificity they deserve. The first consequence is the moisture. When the jet stream's southern branch locks into a position across the Gulf Coast states and begins flowing in a nearly stationary arc from the western Gulf, northeastward across Texas and Oklahoma, and into the Tennessee Valley, it establishes a persistent, sustained moisture transport corridor, a conveyor belt that draws Gulf of Mexico moisture northward continuously, day after day, loading the atmosphere ahead of every disturbance that rounds the base of the western trough, with precipitable water values that are anomalous, not just for the current season, but in absolute terms. The ensemble guidance is advertising precipitable water values of 2 to 2.4 inches across the warm sector of the system, values that represent departures of +2 to +3 standard deviations above the climatological mean for this time of year. 2.4 inches of precipitable water in the atmosphere is the moisture content you expect in a tropical system approaching the Gulf Coast in late August. Finding it in the mid-latitude warm sector of a spring cyclone over Oklahoma and Tennessee is, by itself, a signal that warrants serious attention from anyone who lives in or near the affected corridor. Because precipitable water values of 2 to 2.4 inches do not just fuel heavy rainfall, they fuel the kind of extreme flash flood-producing rainfall rates, 2, 3, and some convective cores approaching 4 inches per hour, that no drainage infrastructure in the central or eastern United States was designed to manage. The moisture anomaly alone, independent of the severe weather setup, is sufficient to make this week historically significant from a flood hazard perspective. The second consequence of the omega block configuration is the instability, and this is where the jet stream going wild begins to translate directly into the most violent, severe weather outcomes. The southern branch jet, locked into its stationary arc across the Gulf Coast states, does something to the atmosphere beneath it that the progressive normal jet stream does only transiently. It maintains a persistent upper-level divergence maximum over the warm sector for days at a time. Upper-level divergence in the atmosphere is like a vacuum cleaner operating on the column of air below it. It pulls air upward from the surface, reducing surface pressure, drawing in surface air from the surrounding environment, and in the process, creating the vertical motion that lifts the warm, moist, unstable surface air into the realm of active convective development. When that upper-level divergence is persistent and intense, which is exactly what a locked southern branch jet provides, the surface environment ahead of each disturbance rounding the western trough does not just become unstable. It becomes explosively, historically unstable. The Cape values the models are advertising for the primary severe weather windows of this event are in the 3,500 to 5,000 joule per kilogram range, 5,000 joules per kilogram of Cape. I want to sit with that number for a moment because it deserves more than a passing reference. The median Cape value for significant tornado events in the United States, events that produce EF2 or stronger tornadoes, is approximately 1,500 joules per kilogram. The 95th percentile Cape value for significant tornado events is approximately 3,000 joules per kilogram. 5,000 joules per kilogram is above the 99th percentile of observed Cape values for any severe weather event in the historical database. It is the atmospheric equivalent of a fuel depot rather than a fuel tank, and the jet stream going wild is what creates it. The third consequence of the omega block, and in some ways the most dangerous because it operates across the longest timescale and the broadest geographic footprint, is the precipitation regime that the blocking pattern establishes and maintains throughout its duration. Omega blocks do not just slow down the weather systems that round their flanking troughs, they trap them. Disturbance after disturbance rotating around the base of the western trough gets slowed to a near stop as it approaches the central part of the block, forced to meander and stall, and eventually cut off from the main flow entirely, before the block's gradual erosion allows them to finally push through. Each of these stalling disturbances is working with the extraordinary moisture that the locked southern branch jet is continuously supplying. Each of them is capable of training heavy precipitation over the same geographic areas for 12, 24, in some cases 36 or more consecutive hours. The cumulative rainfall totals that result from 3 to 4 stalling disturbances moving through over the course of 7 to 10 days of blocking are not rainfall totals in the conventional sense. They are flood budgets. The ensemble guidance is advertising 7 to 14-inch rainfall totals across the primary moisture transport corridor over the duration of the blocking event, with locally higher amounts of 14 to 20 inches possible in the most persistent training corridors and over the elevated terrain of the Ozarks and the Cumberland Plateau, where orographic enhancement adds to the convective totals. 20 inches of rainfall over 7 to 10 days across the Arkansas River drainage, the Tennessee River drainage, the Cumberland River drainage, and the Ohio River system simultaneously is not a flood watch. It is a flood siege. It is the meteorological setup for the kind of multi-river, multi-state, weeks-long flooding that defines water years in the historical record of the Army Corps of Engineers and the National Weather Service river forecast centers. I want you to understand that clearly before the first drop of this event falls. Now, let me talk about the severe weather and tornado threat from the individual disturbances that are going to rotate through this blocking pattern, because each one represents an independent, potentially outbreak-level severe weather event in its own right. And the omega block means they arrive in sequence rather than in isolation, each one compounding the ground conditions and infrastructure vulnerability that the previous one created. The first disturbance, arriving early in the blocking event, fires into a surface environment that is already loaded with the moisture and instability I described, and it does so with a wind shear profile that the models are depicting as exceptional. The hodograph shape, the graphical representation of how the wind changes speed and direction from the surface to the upper troposphere, is showing the long, curved, counterclockwise rotation that is the kinematic signature of supercell favorable environments. Storm relative helicity values in the 0 to 3 kilometer layer are forecast in the 300 to 500 joule per square meter range for the primary initiation corridor, overlapping with the 5,000 joule CAPE environment I described. When 5,000 joules of CAPE meets 500 joules per square meter of storm relative helicity in the same atmospheric column, that I find genuinely sobering to look at in the model output. These are not borderline values. These are not close calls in the parameter space. These are the values that appear in the climatological analyses of April 1974, of April 2011, of the events that defined what the words historic outbreak mean in the context of American severe weather. Please take the tornado threat from this event with the full seriousness those comparisons warrant. The overnight tornado risk embedded within this blocking pattern deserves specific, dedicated attention because it applies not just to the initial disturbance, but to every subsequent disturbance that rotates through over the 7 to 10 day duration of the block. And because the geographic footprint of the overnight risk expands with each successive event as the squall lines that consolidate from the afternoon supercell phases push further and further into the Ohio Valley and the Tennessee Valley communities that are less culturally prepared for finding themselves in the core of a major severe weather event. Every overnight window of this blocking event, from the first squall line through the last, carries the QLCS tornado risk that I have described in detail in previous forecasts. The embedded mesovortices, the 5-minute or less warning lead times, the sleeping households, the alert systems that fail at the worst possible moment, and the cumulative effect of multiple overnight severe weather events across the same corridor over 7 to 10 days is a compounding of alert fatigue that I want to address directly and honestly. Alert fatigue is real. When tornado warnings cover your county 3 nights in a row and nothing happens to your home, the 4th warning feels less urgent than the first. The psychological literature on this is unambiguous, and the behavioral consequences in severe weather events are documented. Please, for the duration of this blocking event, resist the alert fatigue response with everything you have. The jet stream going wild does not go wild for one night and then settle down. It goes wild for the duration of the block. Every warning deserves the same response on night 7 as it did on night 1. Y'all call is the system that makes that consistent response possible, even when your own psychology is working against you, because it does not care about your alert fatigue. It does not know you have already been through 3 overnight warnings this week. It simply calls your phone the moment a tornado warning covers your GPS coordinates and lets the urgency of a ringing phone do what the urgency of a push notification has stopped being able to do by night 4. $14.95 for a full year. Link in the description. Please set it up before the first disturbance arrives. The infrastructure dimension of a 7 to 10 day wild jet stream blocking event is something I want to address with the full seriousness it deserves, because the infrastructure impacts of an event of this duration and this geographic scope are not the 1-week story that a single major severe weather event produces. They are a month-long story, possibly longer. Power grid infrastructure across the south central and eastern United States is going to sustain repeated damage from the combination of straight-line winds from successive squall lines, ice loading from the wintry precipitation that the western trough will produce at its northern fringe, and the debris loading from the tornado damage paths that will require grid repairs in communities where the infrastructure is already stressed from the previous event in the sequence. Utility mutual aid resources, the crews and equipment that travel from unaffected regions to help restore power after major events, are going to be stretched thin across multiple states simultaneously as the blocking pattern maintains the active weather regime for a week or more. Communities that lose power late in the event sequence may wait longer for restoration than they would after a single, isolated event of equal severity, because the available restoration resources are already committed elsewhere in the event sequence. Road and bridge infrastructure is going to sustain repeated flood damage from the successive rainfall events, with the later events in the sequence damaging infrastructure that was already weakened by the earlier ones. Agricultural infrastructure, grain bins, machine sheds, irrigation systems, standing crops, is going to absorb blow after blow from successive hail events, wind events, and flooding events across the same corridor, with cumulative damage that far exceeds what any single event would have produced. The wild jet stream does not just produce wild weather for a day, it produces a sustained assault on the infrastructure and the communities in its path for the duration of the blocking pattern. Please prepare for that duration, not just for the first event. Here is your preparation framework for a 7 to 10 day wild jet stream event. And I want to give it to you in terms that reflect the sustained multi-event character of what is coming, rather than the single event preparation guidance that suffices for a more typical severe weather week. Your tornado shelter needs to be not just identified and accessible, but stocked. Water, phone chargers, a battery-powered weather radio, any essential medications, anything your household needs to shelter for an extended period if the first event produces damage that complicates access to the shelter for subsequent events. Y'all call needs to be active on every phone before the first disturbance arrives, and it needs to stay active for the full duration of the blocking pattern. Because the tornado risk does not end when the first squall line moves through. It resets with every new disturbance that rounds the base of the Western Trough. Your flood route planning needs to account for the cumulative deterioration of road infrastructure over multiple successive rainfall events, roads that are passable after event. One may not be passable after event 3, and the flood stage thresholds on the river systems near your home are going to be reached earlier in each successive event, as the soil moisture and antecedent river flows increase with each round. Your power outage preparation needs to be calibrated for a multi-day to potentially multi-week disruption, not a one-day inconvenience. Backup power for essential medical equipment. You plan for temperature management if the outage coincides with the heat that the Omega Block's central ridge is going to maintain across the warm sector. A communication plan for elderly and vulnerable family members who may not be able to sustain a week without grid power. Charge every device before every disturbance, not just before the first one. Fill every prescription now before supply chains are disrupted by the event sequence. And please, share this forecast with the people in your life who are currently thinking about this week as a single severe weather event, rather than as the opening chapter of a sustained jet stream-driven weather siege. The jet stream is about to go wild. The people in its path need to prepare for the full duration of that wildness, not just for the first day. I'm going to be live through every disturbance in this sequence, from first initiation through final flood crest. Subscribe, hit the notification bell, and I will see you all in the live stream. I love every single one of you. The jet stream is going wild. Please be ready for what that means. Stay safe out there.